Okay, ji, Assalamu alaikum to all attendees. We'll be starting our discussion for today. We are into week number 14, right? So it means after this one, we are left with 2 more weeks of teaching, right? So we'll try to conclude our contents within the next couple of weeks. Okay. So for today and tomorrow, we have a couple of topics, right? We hope to complete them within these 2 days. They are not very long; they are short topics, right? But they are important and useful. So when you are writing program, they can help you make your programs more effective, right? So the first of these is templates, right? That will try to wrap up within 45, 50 minutes, right? It's something very simple. So hopefully we'll be able to do it today, and we'll be left with some time to discuss what we need to see tomorrow, right? So I'll be starting this discussion. So the idea of templates is actually to generalize your program, right? We have already seen that reusing existing classes, existing programs, existing functions is something very useful, right? So it's a similar concept, but with slightly different syntax. So we'll be looking at function templates, and we'll be looking at class templates, right? So these are the two, you can say, things that we'll be looking today. And the whole idea is to generalize your program, right? So when we talk of generalizing program, we have already seen function overloading, right? If you remember, in function overloading, we have a function with the same name, but the number of or the types of arguments, they are different, right? For example, on the screen you can see a function square. So we can compute the square of an integer, and we can compute the square of a real number as well. So you see this, the name of the function is square. User will always be calling the function with the same name, but when the user passes an integer, the integer version will be invoked, right? And when the user passes a real number, that version would be invoked, right? So when we are doing templates, the idea is very much similar, right? That we want the same function to accept different types of argument, but now we'll be going a step further to function overloading. Okay, so let me just open the board, and then we see it with the example that what exactly we want to do, right? So first, what I'll be doing is I'll be writing two functions, very simple function, which are simply adding two numbers. Okay, so I'll be writing the integer version. I'll be writing the float or the double version. So I'll be writing an example of function overloading. So say we have a function void add. Okay, it is accepting two integers, integer a and integer b. Okay. Ideally, this function should return a value, but just to keep it simple, I'm just uh, not returning anything. So I say int c is a plus b, and I'm just displaying the value. Okay. Now this version that you see on the screen, it is adding two integers. Now we write an overloaded version of exactly the same function, but the one that would be adding to uh, doubles or float, whatever you want to call it. Okay, so we have two integers, sorry, two real numbers a and b. When we add them, we again get a real number. So I write it c is a plus b, and here you can simply display whatever you have computed. Okay, now if you see both of these version, the one on the left side of your screen and the one on the right side of your screen, you see they are exactly similar. The only difference is what I'm highlighting, that this data type. Hmm. Okay, so whatever I'm highlighting on the left side and the right side, you see this is the only difference between these two functions. Rest everything is same. Okay, so let me just write the common parts and leave the different parts, and then we see how we can do something better. Okay, so we have void add. Okay, and this was a different part, so I'm just leaving it blank, a and B, right? Then we say C is A plus B. Okay, now you see, just focus on the function that is written at the bottom of the screen. I have left blanks, right, which are for the data type. Okay, so you see, if you replace this blank with an integer, what you get this version of the function, means the function that will be adding two integers. And in the blank, if I write a double, okay, fill every blank with a double, then you get this version of the function. Okay, so you see, uh, once we are doing function overloading, so mostly the function is doing the same thing. Okay, it's only the data types that are different, that you need a version that can work on integers or characters or real numbers or anything else, right? So as I have shown you that if you simply replace this blank with an integer, you get the version that will add two integers. And if you replace the blank with a double, you will get the version that is adding two doubles. Okay, so why we are writing this two times? Okay, it's fine, we know we do like that in function template. So you see, we can write this function only once, and we can also pass data type as an argument, not exactly as an argument, but when we are calling the function, we can somehow tell that we want to add two integers or we want to add two doubles. For example, if I call this function with two integers, okay, then I want that this blank is replaced with an integer, okay, so that I can add these two. And when I call this function with, say, two real numbers, then I want this blank to be replaced by a double. Okay, so what we will be doing, we'll be only writing this function once, and when we are calling, we can generate two versions of this function, one version which is adding two integers and the other one version which is adding two floats. Okay, so let me just do that. Let me tell you how to do that. Okay, so for that we use template. Okay, what we do, I'll write that at the end first. Let me just okay, so this is exactly what we were doing previously. Okay, C out C, and that's it. Okay, so when you are implementing a function with templates, when you are writing before the body of the function, you will have to write, this is something new that we are writing, template. Okay, and then you will put these angle brackets. Okay, within angle brackets you will write, this is a syntax just, okay, so maybe it seems strange to you in the beginning, but you will get used to it. Okay, now see, we have written template type name, this is fixed, you cannot change it. Okay, but after type name you just have to put anything, just like you choose name of a variable. You can call it data, element, item, abc, xyz, anything that you like, just like you choose the name of a variable, right? So I'm calling it element. Okay, but please remember, this element is not a keyword, it can be anything. You can call it data, a, x, y, z, anything. Okay, so you can use any, just like you choose names of the variables. Okay, now whatever I left blank, here you will write the identifier that you have chosen. Okay, so instead of calling it integer or character or float or double, we are calling it element. Okay, now let me explain you how this will work. Okay, so suppose from the main, someone is calling the function add and passing two integers. So when you call this function, okay, 2 and 3 are integers. You can take variables or you can directly pass numbers. So what will happen? This element will be substituted, you can think like by an integer. Okay, so this function will add two integers. And if you call this function like this, okay, so what will happen, this element will be substituted by a double, so it will be adding these two real numbers. Okay, so now see, this is important, this is the new line which I'm highlighting, that whenever you want to write a function with templates, Okay, and for the time being, we are talking about standalone function, right? We are not talking about classes. I'll come to that later, right? So these are just global function, like you want to add two number, you want to make a calculator or something, right? So these are global function. So this highlighted part which you see at the top, this is the new part. Okay, so I'll repeat it many times, don't worry. You write a template, then you put angle brackets. Within angle brackets, you use the keyword type name. It's a keyword, right? And after type name, you can choose anything, any name, just like you choose name of a variable. I have chosen element here. Okay, now element can be anything. Element can be an integer, float, double character, anything, right? So now within the body of the function, instead of using integer or float, you will be using this element. Okay, you don't use integer or float. Now you'll be using this. Now when you will call this function with two integers, you can think that this element would be replaced by int, so it will be adding two integers. And when you will call this function with something else, the element would be replaced by that data type, right? So let me just show you this example again on the slide, so that you have a global view of what we have been doing, right? So this is the example that I had shown you, that we are doing function overloading. So template is actually function overloading, but we don't have to write the function multiple times. We just write the function only once. Okay, so what you see in the red is the difference between these two functions. Rest everything is same. So we say, okay, why not make a single function? Okay, and when we are calling this function, just replace this blank by a data type. So as I told you, when you will replace it by int, you get the version which is on the left side. If you replace by double, you get this version. Okay, so what do? We write template. Within angle brackets we write type name, and here you can write anything, right? A, B, C, X, Y, it's your choice. But where you are writing here, the same identifier you would be writing within the function. Okay, so now we have this function. When you call it with an integer, you will when you call it with integer, it will work. When you call it with float, it will work, right? And one important thing is that the you for this type name, you have two choices. Okay, you can either write um, type name here, or you can also write class here. Okay, but intentionally in the first example, I'm not using the keyword class, because you do not confuse it with the class that you make in object oriented programming, right? So this is the same keyword, but here it is serving a different purpose. Okay, so what you see here in blue, type name, it's a keyword. You can either write type name, or you can write class. Okay, but please be careful. When you write class here, don't confuse it with the classes that you have already been making. Okay, now let me show you one more example, and then maybe we can discuss. So you see, this is an example which is computing absolute value of a number, right? What is an absolute value? If I have five, if I have five, the absolute value is five. If I have minus five, the absolute value is also five. Okay, so in other words, absolute value does not have a sign, right? If it's a negative value, you just pick this. If it's a positive value, you pick this. Okay, so it means that I can make a function absolute. Okay, if the number is negative, okay, I multiply it by another minus one. So what will happen? The negative number will minus five will become five. Okay, so if the number is less than zero, I return minus number. If the number is greater than zero, I return is it as it is. I don't do anything, right? If it's five, answer is also five. If it's minus five, I will do minus 5, so it will become 5. Okay, so you see, we can compute absolute value of a integer. We can also compute absolute value of some other data type, right? Float or double. So when you want to implement it with template, instead of using integer here, we are using some identifier, and we are implementing it with template. Now if you call this function for integers, it will work. If you call this function with some real number, it will work. Okay, so you see, now you have made only one single function, but it is working for multiple data types, right? So this was another example. We have a couple of more examples, but I think before that, we can discuss your queries if there are any. Okay, now let me just quickly extend this example, that as few of you were asking, and I also told you that sometimes we want a mix of argument, right? We can have real number, and we can have an integer, right? So how to do that? And in that case, of course, you also have to be careful that when you are adding an integer, okay, and maybe a real number, so the answer would also be a real number. Okay, so this is something we need to take care of. Okay, so let's see what will happen if we have a mix of data type. Okay, so maybe I just write a program, a different example. Okay, so we say template. Okay, type name. Okay, so and now I'm calling it a. Okay, so that every time you should know that this can be anything. Okay, and then I make a function which is returning an integer, int find. Okay, now what this function is accepting, it is an accepting an array. Okay, and it is also accepting another value s, and it is accepting size of array. Okay, now you must have noticed that when you are doing template, it is not necessary that everything, if I'm writing a here, everything is a. Why? Because you see I'm passing an array, and this last argument is the size of array, because when you use array you need a for loop, and in order to have a for loop you need to know the size of the array. But you see, whether array is of integers or float or character or points, size of array is always an integer, right? So that's why you see an integer here. It is not please don't think that when you are doing templates, if I'm writing type name a, everything has to be a, right? So you see, here we have perfectly an integer. Why? Because whatever is the type of the array, the size of array will always be an integer, right? Okay, so now let me write a small piece of code, and then we discuss what we are trying to do. So we use a for loop, I less than size. So this is why we needed size, I plus plus. Now what are we doing in the for loop? We say if equals s. What is s? The value that we passed. Okay, so we say return I. Okay, and the for loop terminates here, and here I am saying return -1. Okay, now let's see what this program, or this function rather, is doing. Okay, so you see we have an array. Suppose my array is 1 2 3 4. Okay, and when I call this function, I pass this array, and I pass it value, say 3. Okay, so this s is 3, and this array is actually this array. Okay, and this size is 4 because there are 4 elements in the array. So what will happen, you have a for loop, you are actually checking every position of the array, and you are comparing it with s. What is s? So s is actually a value that you are searching in the array. Okay, so what will happen, you will first check, it is 3, no, it is 3, no, it is 3. So what it will return, it will return you the position at which it found this value. And if the loop terminates, your program never comes here, it means you did not find a value, it will return -1. Okay, so let me just give you a proper example. Maybe I pass it 10 20 30. This is an array. Okay, and I pass 25 as s. So what will happen, it will search, this is 25, no, this is 25, no, this is 25, no. So it means the loop will terminate, the value is not found, and you are returning -1. On the other hand, if I pass it 20, this is position 0 1 2. So what will happen, it will check the first position and the second position. 20 is found, this condition is true, so it will return I. It means it will return 1, which is the position of this element in the array, right? So this is you can say one example on which we'll be developing the next concept. So this function, in summary, is a search function. You pass it an array, and you pass it a value which you want to search along with the size of the array. It will check every single position in the array. If the value is found, it will return you the position. If the value is not found, it will return you -1. Okay, so now let's go back to the slides and see how we are doing that. Okay, so this is exactly the same function which I had written, just slowly so that you understand, and now we can discuss it here. Okay, so now you see we can have an array of integers 1 2 3 4 5, and we want to search 5. Okay, or you can have an array of float or double in which you have values like this and you want to search value 5.5. Okay, so you can find call this function find. You can pass it integer array and the value to search. This is the size of the array. Okay, similarly you can pass it the array of doubles, the value to search, and this is the size of the array. Now, as you were saying, the problem will arise when the first argument is integer, okay, but the second argument you have passed is a double or a float. Okay, so what you are doing, the array is of integer but you are trying to search a float in that. Okay, so you see there will be a problem. Why? Because it is not possible that the first one is an integer and the second one is a float. So if I go back here, so you see here you have a type, here you have a type, or a, or whatever you are calling it. So either both of these will be replaced by an integer or both will be replaced by a float. It is not possible that the first one is an integer and the second one is float. This is what we are trying to do. So that's why your program will not compile. Okay, it will complain because you are passing it an array of integers, and the second, this a type, the value you are searching was a float. Okay, so this was the problem. And what is the solution to that problem? It's fairly simple. Instead of having two type names, or here you can write keyword class or type name, whatever you like, you can have two different identifiers. Okay, you just put a comma here, this is a comma within the angle bracket. So now you have two identifier, one we are calling a type, the other we are calling b type. Okay, so the array is a type and the value you are searching is b type. Now if you pass it an array of integers and you search an integer, both a type and b type will be replaced by an integer. So you can search an integer in an array of integer. If both are float, this is fine. A type will be float, b type will be float. And now you can also do this, that the first argument is an integer array but the second argument is a float. So this will work perfectly fine. Why? Because a type will be replaced by int, b type will be replaced by float, and similarly the array can be of float and the b type can be you can say integer, right? So this is how you actually implement it. And now if you will call this function using a mixture of integer and float, this will work perfectly fine. Okay, so this was we'll do some more examples, but now I think we are approaching 11 o'clock, which is your time for quiz. So let's take a pause and we'll continue our discussion after that. Okay, let's get back to our discussion. I hope you were able to solve the quiz, right? It should not have taken more than 5 minutes, right? Anyways, so far in today's session, we have seen function templates, right? The advantage is that you have to write the function only once, and using the template you can define a whole family of forward-loaded functions, right? So the syntax is fairly simple. You just use the keyword template and then you put angle brackets, and within the angle brackets, just like you are passing data as an argument, you are actually passing the data type as an argument, right? So you actually use the keyword type name or you can use the keyword class. Okay, and then after that you can use any identifier, and that identifier you use in the body of the function, right? For example, these are the two examples that you see on the screen. You can write template angle bracket type name, anything like t, and then you can write the body of the function. And as I told you, in place of keyword template you can also use the keyword class, right? But you should be careful that do not mix this keyword class with the classes that you have been making, right? Here it is serving a different purpose. Okay, so this was basically if you have only one type name, then within the body of the function, as we had seen in examples, you cannot have a mix of arguments, right? For example, it is not possible that you have one integer, one float, and so on. But if you want a mix of arguments, right? For example, a function taking two arguments, you want the first one to be an integer, the second one to be a character or anything, then you have to use the type name as many times as you want, right? For example, the example that you see at the bottom of the screen, we have written template within angle brackets type name t1 t2. Now t1 and t2 can be different data types or they can be same. Okay, so you see the advantage is that Now you can have one argument, both the arguments can be integer, both the arguments can be floats, or you can have a mix of an integer and a float, right? So this is the advantage of template. So we have seen function templates. We'll start class templates, but before that, if there are any points, we can discuss those. Okay, now just like we have seen function templates, we can implement or extend the same concept to the classes, right? You see, in classes we have data members, okay, and suppose you have a class in which there's an integer or an array of integer. So you see, sometimes you want an array of floats, maybe sometimes you want an array of some other data type. So instead of making multiple classes, you see, it would be very handy if we can have something that when I create one object, I have integers as data members. When I create another object, I have floats as data members. So you see, by writing only one class, it will give you so much of flexibility that you would be able to create objects, and each object will have data members which will have different types. Okay, so this is the general idea. Now let me explain this idea that suppose we have some class, okay, which has an array, right? So when there's an array, we need to specify the size of array, which cannot be a variable, right? So I'm taking constant integer, say size, which is 128, something like that. Okay, and now we have a class. Okay, let's call it anything because we don't need to put anything here. We're just discussing it conceptually. So it will have some member functions, it will have some data. Okay, now within the class, suppose I take an array of integers, integer array, and then I write size here. Okay, sorry. Okay, so this is a class. We have a array as a data member. So you see, now you can create the objects of this class like test t1, t2, and each of these objects will have an array of integer like 128 integers. Okay, but now assume that we want a situation like this, that for t1 I need an array of integers, but for t2 I need an array of floats. So you see, if this is the situation, this can arise, right? So if I'm doing it without templates, I will have to make two different classes. Okay, in one class I will have integer here, in another class I will have float here, but rest everything would be exactly the same. You see, because the functionality of the class would be same what it is doing. So it is not a very smart idea that I make two classes in which everything is exactly the same, only one data type or a couple of data types are different. So this is where we'll be introducing templates. Okay, so how do we do that? Just like we did with functions, before the class definition, here you write the keyword template. Okay, then you put angle brackets, then you write the keyword type name. Okay, and after that you can write anything. For example, I am writing t, you can write a b c x y z, anything. Okay, and within the body of the class, instead of writing int here, okay, I get rid of this int, and here I'll be writing t. Okay, of course you can have other data members, you can repeat this. Okay, I'm just giving you example with one array. You can have some other data members like so it can have a mix like integer, float, everything, but of course I'm giving you example with one data member because this is the data member on which we want to apply templates. Okay, now if we go back to the main. Okay, now we need to create two objects, and we want that one of the objects should have an array of integers, the other object should have an array of floats. Okay, so you see, what is the syntax now? You write name of the class test t1. This is what you were doing without templates. Now if you are making an object with template, there is a slight change. You simply write test. Okay, but before creating an object, you put angle brackets here. Now what do you want this t to be? If you want this t to be an integer, within the angle brackets you write int. and then you write T1. Okay, now what will happen? You have created an object T1. Okay, just compare this syntax with this syntax. Okay, so you have created an object T1, and T1 has an array of integer because you have written integer when you were creating an object. Okay, so this is the new thing. When you write this int in angle bracket, what happens? This T will be replaced with an integer. So it means the object has an array of integers as a data member. Now you can create another object which can have some other data type. So for example, if I write test angle bracket float and I create another object T2. So now, since you have given float in the angle bracket, so for object T2, you have written float here. So when you create T2, this T will be replaced by a float for T2. So you can say that there are two objects of my class test. The objects are T1 and T2. T1 has an array of integers as its data member, while T2 has an array of floats as its data member. So you see, it's a very, very powerful concept. Uh, you save so much of rewriting of code that you simply use template, and now you have much more flexibility in your program, right? The only new thing is this syntax of angle brackets. And why do we need it? Because you see, when we were studying function templates, we did not need it, because when we were calling the function by looking at the data type of the arguments, your program automatically knew which version of the function to call, whether we want to add to integers or float, right? Because when you were calling, your program would automatically know that. When you are creating an object, the program does not have an automatic way of knowing that whether T1 should have an array of integer or float or character or something else. That's why we need to tell the program. And the way we tell is by putting these angle brackets. Okay, so if you look at the syntax directly like this, it might appear a bit strange, but it's always a good idea to compare it with the syntax which you already know. So this is the syntax test T1 which you already knew. All we did is that after the name of the class and before the name of the variable or the object, you just put these angle brackets and you introduced integer, right? So this is the way we introduce class templates. Now there's one more detail that I would like to give you. You see, when you have this class, you will definitely have some functions in the class as well. Okay, so for example, you have a function display. Okay, so let me just write that function and then we discuss. Okay, so if you are defining that function within the body of the function, sorry, within the body of the class, okay, then there is no other thing you need to do. Okay, for example, let me just rewrite it with a different organization so that we can discuss it easily. Okay, so now here you have private and you have an array t array of size 128. Okay, and within public, suppose I want to make a function display, so you will have void display. And if you want to display this array, whenever there's an array, there's always a for loop. So you will write for int I equals 0, I less than size, and I plus plus. And here you can write cout array of I, and this is the end of the function. Okay, so when you are using templates uh, and you are using class template, you are giving body of function inside the body of the class, then there is no other syntax change. Okay, this is the only syntax change that you need, which you see on the class. You just write template type name and t or anything else, that's it. And you know how to make objects of this class, we have already discussed that. But you see, normally we are splitting our program in multiple files. If you remember, we have .h file in which we have only class definition, and we have a cpp file in which we put all the functions. Okay, so in other words, what I'm trying to say is that normally if you are writing big programs, you don't give body of function here, Okay, so I'm just removing it from here. You actually give the body of this function outside the class. So here you simply put a semicolon, which is telling the function prototype, and you will put the body either after the class or in a separate file. Okay, so if you remember, if you are not using class template, then what we were doing, you used to write the name of the function, name of the class, scope resolution operator. Okay, and then you can write this display, and here you can give the body of this function. Okay, so you see, the only this was without templates. Okay, this was something we introduced new. Okay, uh, void name of the class, scope resolution operator, display. So I told you how to read this double colon. The name of this operator is scope resolution, but you read it like belongs to. So we read it in this direction, the display function which belongs to class test, we are giving body of that function. Okay, so this is how you are doing without templates. If you are using templates, then you need to add something more to the syntax. Okay, so what will be that? Let me just do again. Please don't worry if the it's only a syntax. Okay, nothing much. So before body of every function, you need to repeat this. Every function. Okay, if the class has 10 functions, you need to repeat this with each of the 10 functions. Template. Okay, so this is something that you will repeat with every function, and then you will write the body void. Okay, here you had class name, then scope resolution operator. So okay, so we are just looking at this and we are writing this. So I put the name of the class. Okay, then something new is, let me change the color so that you know what is new here. Maybe this one. You again put angle brackets here and you write T. Okay, and then you simply write what you were writing. Display, and you give the body of the function. Okay, now let me explain what I just did. So you see, first thing you should remember is that if you are giving the body of this function inside the class here, okay, then you don't need any of these things. Okay, you don't need scope resolution operator, you don't need template type name with every function, because once you have written here, that is sufficient. You can give bodies of all the functions here. There is no other syntax change. But as I keep telling you, that when you are writing bigger programs, right, it's not a good idea to put body of function in the class, so we give body of function outside the class. If you remember, when we give body of the function outside the class, we use scope resolution operator, right? So this is how you were doing it when you were not using templates. Return type, name of the class, scope resolution operator, name of the function, and then you can give the body of the function. If you are doing the same thing and your class is implemented with template, then when you are giving the body of the function, of course you need to write this with every function. Template type name T. Okay, this you already know from function templates. And this is the new thing. Okay, this part, that here after the name of the class, you again need to put angle brackets, and you need to put the identifier which you used, and you can give the body just like you were giving it previously, right? So initially, if this syntax is confusing for you, maybe in the initial programs you can give the body of all the functions inside the class, but later, once you are comfortable with templates, then you can shift to this syntax. Okay, it is only a matter of syntax. From the viewpoint of how you write the program, that would remain exactly the same. Now let me show you the same example, maybe in a neater way on the slides, so that they can serve as a recap of what we have discussed. Okay, so as I told you, that when you are using classes, you can perfectly implement classes with templates. So you write template type name. Okay, so the class has an array. Now I want this array sometimes to be of integer, sometime to be of float, so that's why I'm using template. Here I can write anything. For example, I write element here. Now if you want an array of integers, whenever you will make an object of this class, you will write test int t1. So t1 will have an array of integer because this element will be replaced by an int. Similarly, if you want another object, test T2 in which you want an array of character. So T2 will have an array of characters, T1 will have an array of integers, right? And then as I told you, when you are giving the body of the function outside the class, okay, please remember outside the class. So this is the syntax that you know that we use when we are using we are not using any templates. Okay, so we see we are basically simply displaying the members of an array by a for loop. But if you are using templates, okay, so what you do, before this function here you will write template type name, and after the name of the class you will put angle brackets again. Okay, so this is the syntax that we use with templates. Okay, now you can compare both of these. So there's just a syntax change. The difference is this, which you need to put with every function, and another difference is this. Okay, so this is how you do it. Another function which is assigning values to the elements of an array. The name of the function is assign. We are passing a value. For example, I am passing it 2. So what will happen, all the elements will be initialized with value 2. Like, so this is just like initializing an array, because when you are initializing integer, you simply use the assignment operator. But if it's an array, you have to use a for loop and assign a value to every element of an array. Okay, and then as I told you, when you have to create objects, so the angle brackets and the data type that you see here, that is the only new part. Rest everything would remain the same. The way you call the function with a normal class, you use exactly the same syntax to call the function, right? If it's an object, you write s1 dot and name of the function. Okay, if it's a pointer, you use p arrow and name of the function. So you see, rest everything would remain exactly the same, no changes, but we have much more flexibility that now I can create multiple object of this class, and of every object can have an array of a different data type, right? And not necessarily it's always an array, it can be anything, right? You can have simply two integers. For example, when we were making the class point, okay, if you remember class point, so sometimes we say point has two coordinates, int x, int y, right? So it means I can make points like 2 3 4 5. But what if I want a point like 2.3 and 6.4? Okay, this can also be a point, because in my if this is x-axis, this y-axis, maybe this is a point which is like 2.3 and 6.1. So in that case, I want these to be float. Okay, so if you see, if someone wants point x coordinate and y coordinate to be integer, they can use template, so that the user now has the flexibility that whether their points coordinate would be integers like 2 3 4 5, or they want very precise point locations like 2.3 and 6.1, right? So you see, the whole idea is making your classes much more generic. So this was all about function templates and class templates. If you have any comments, we can discuss those before we start the next topic. Thank you.